Um, Interesting. Is my audio not working? Um, Interesting. Is my audio not working? Okay, who knows what that is about. Um, it seems to be working, so. Alright, welcome back to the DX12 programming streams. Where we left off yesterday, we have a nice teal render target, but no triangle. And you can also notice in the process memory tab, yeah, we got like pretty severe memory leak to deal with. So, first thing we're going to do today is we're going to actually get that triangle on screen. I realized last night that there's a whole bunch of state that we are not setting that we need to set in order to actually render anything. So, first order of business is to actually do that. Uh, so, before we set the pipeline state, we actually need to set the root signature. Um, Not entirely certain why, because the pipeline state knows its root signature, but we will follow the recommendations for now. We also need to tell the input assembler what kinds of primitives we're drawing, because even though we're not using vertex buffers or index buffers or anything like that, we still need to tell the rasterizer what kind of primitives to rasterize, or rather, what kind of primitives the vertex shader corresponds to. Because we in the pipeline state, we have told it what kind of primitives it'll rasterize. That's not necessarily the same type of primitive that gets input, because you have the option of having, say, a geometry shader in the middle that takes, say, a point primitive and then expands it into two triangles, right? So you would have points as inputs and then triangles as outputs. So we know that we're rendering a triangle, but we need to tell input assembler that we're rendering, that we're reading triangles, or that vertex shader is producing triangles. We're not actually reading any data in the vertex shader, which makes this a little more confusing. But so we need to set the primitive topology to okay, that's interesting. Um, Why does DX12 not have a triangle list? This is type. That's not what it's asking for. Okay, I guess it's a type def off of this. Sure, all right. I need D3D. Primitive. The triangle list. Okay. One more important thing that we're not actually doing is we never actually set the output target. So we can render a triangle, we're just not actually outputting anything to anywhere. So I don't know if rasterizer discards that or if it just gets to broth and then dies. But we need to actually set our render target. That's OM set render targets. I think this is this. Sure, this is true. And we don't have a dump buffer. So now this may not be enough, but I'm going to test it to see. Okay. So the other state that we need to set is we are not setting viewport and scissor. And I don't think those default to anything reasonable. Okay. Is that sufficient now? No. Right. same for scissor. Quite annoying that these two very similar calls have very different ideas about how rectangles are defined. All right, so that's sufficient. Hey, look at that. We have a triangle. Awesome. So that's that. Now, the next thing we want to handle is this memory leak. And so the reason we're having this memory leak is that, well, it's actually two reasons. One is every frame we create a command list, and then we record to that command list, and then we never do anything to release that memory. And we just create a new command list every frame, and we leak the pointers and never do anything with them. So that's not great. The other thing is that we create this command allocator. This is what actually allocates the GPU memory for command lists. And so we have to reset this regularly in order to reuse the same memory on GPU. The problem is that we cannot reset the command allocator until all of the commands allocated from it are done running on the GPU. If we reset it early, then we've just invalidated command buffer memory on the GPU, and bad things will happen. So in a more full-fledged engine, you would have one of these command allocators per, well, one of them per rendering thread. So that will be whatever threads are actually writing your command lists. And then per frame. So we have multiple frames in flight when we are rendering. That's necessary in order to avoid stalling the GPU. So we have to have one frame in the process of rendering, another frame that is in the process of being recorded, and a final frame that is just on the screen. So in order to figure out when we can free the memory under this command allocator, we have to have a fence on the GPU that gets set at the end of that frame. So then we can check and see, is this fence, has this fence been set? And if it has, then we know that that frame has completed, and we can free the command buffer memory that was used for it. So that's going to be quite a bit of work to get correct, I believe. But we can start by not creating a new command list every frame. So start by creating the command list, and then at the beginning of the frame, we will reset the command list. This takes the here and lifetime state, but we don't care about that one. This is, we're allowed to do this as soon as we execute the command list. We no longer care about its contents, because this is just like a CPU side recording of what commands are happening. So as soon as we have submitted that command list to the GPU, we no longer need the actual command list to be the same command list. Like, we can reset it and reuse it immediately because the command allocator is what actually controls the GPU memory of the commands, and it's the thing that controls the it's the thing that we need to fence on for following frames. That was not a good explanation, but I hope it helped somewhat. So again, in a fully fledged engine, what you would do is you would have some large shared pool of command lists that you would pull from on each of your recording threads, and then reuse every frame. So like at the end of the frame, once you submit your commands, you would go through and reset every command list that got used, put them back in the pool, and then you can go forward. It's only the command allocators that have weird lifetime constraints. So we will still have a leak because we're not handling command allocators right now, but it should be a smaller leak because we're not leaking the command list every frame. Yeah, so it's still leaking. It's not leaking quite as much. So in order to handle the command allocators, we need to allocate multiple of them because we don't want to wait on the frame we just submitted, because if we do that, there's going to be some gap of time when the GPU doesn't have anything to work on. and that's bad. Uh, the main way to make something render fast is to keep the GPU as busy as possible all of the time. If your GPU is idle, you screwed up somewhere. Or you haven't necessarily screwed up. You might just not have enough work for it, but like you're not going as fast as you can if your GPU is ever idle. So we're going to have 3 of these, and then we need to create them. And this is, again, a rather hacky way to handle this. We will be doing better later, but for now, this is what we will have. All right. So everywhere that we are using and allocator, all right. So now we want to say reset on this command allocator. No. Because this will actually free the GPU memory and presumably some CPU memory as well, and just it will mean that we're not leaking command memory indefinitely. So right now, this will not work. And the reason it will not work is that the CPU can run ahead of the GPU, and so it may start rendering frame plus 3 before the GPU has finished rendering that frame. And when that happens, it will end up resetting the command allocator out from underneath the GPU command processor, and now your command processor is reading memory it shouldn't. I don't know whether it's actually going to be unmapped at that point or what, but if it does work, it only happens to work rather than actually being correct. This actually also has a, so should check. So in order to make that safe, we need a fence. Okay, so should be simple enough. Device created. Yes. 0, it's unsignaled. Going to assume we don't need any of these. Yes, this is very sloppy. We should probably be keeping all of our per frame state in a single structure so that we can be consistent about counts for things more easily. I'm still in brute force to get things correct mode, and we will refactor later. So, after we execute our command lists, we're going to do a signal from the graphics queue to an inference for buffer set to 1. Then up here at the top, before we reset the command allocator, we need to wait on that that fence so that we don't proceed until the GPU is done with it. Which I think we just passed the fence in. No, we need an event in order to do this. Okay. Okay, so don't care about security attributes. We do not want manual reset. Start it as set so that we will not, we'll be able to acquire the image on the first frame easily enough. Do I care about name? Select. Right. Oops. There we go. Okay. So now we wait for we'll wait forever because it doesn't matter how long it takes. It's not safe to destroy this until the event has completed. I need to tell us to set that event. Hmm. I think that's correct. I guess we will find out. Interesting. Okay. Looks like we may not be able to reset a command allocator if it hasn't recorded anything. That seems weird. Oh, right. Yes. So we can't do this because we already created a command list that is using that that command allocator. So what we need to do, go ahead and close that. So we're recording an empty command list because we need to create the command list. I don't know if you can create a command list that doesn't point to a command allocator. But that should close it so that we can then reset the command allocator, reset the command list, and go on our merry way. Excellent. Okay. So you can see that we are rendering our frame and our process memory is staying steady at like 31 megabytes. So that's awesome. That means that we are handling main buffer lifetime correctly, which is a big step forward. So that's cool. The next thing I want to do is I want to set up the API debug layer for DirectX 12. I know that the Vulkan debug layer is extremely useful. And so I want to have that same sort of thing on DX12. So I know it exists. I do not know how to set it up, so we will figure that out. So I think we need to get D3D12 debug and turn on the debug layer, and that should be it. So probably do this. We don't need a device for this. I think we should do this before creating the device. Good work now. Yeah, all right. Oh, interesting. Yeah, here we go. So most of the issues are that we are not barriering correctly. I'm really concerned about this command allocator was reset after the command list was recorded issue. I wonder if our signal is not actually doing the correct thing. Like, is it immediately setting the event? But we will worry about that in a little bit. First, we want to get the resource barriers correct. I know how to do this in Vulkan. I don't know how to do this in DX12. So basically, you need to transition resource state in order to do different things with resources. So, for example, if you want to find a render target, you have to transition the underlying texture to be in the render target state. Otherwise, rendering to it is invalid. Similarly, in order to present, it has to be in the present state. And if you wanted to read that texture in a shader, then it would need to be in a shader visible state. So we will need several barriers in our frame. First is here, before we set the render targets and before we clear the render target, we need to actually transition that target into the render target state. And then before we present, we have to transition to present state. Now, the transitions have to be part of a command list, so it won't be it'll be just right after the draw that we transition back to present, but the point is that it needs to be in present before we can present with it. Easy enough. So these are not conceptually that difficult, at least not for resource transitions, but they are a lot of typing. So to resource barrier, one barrier here. Do we actually have the buffer resources saved out somewhere? That would be really useful. No, of course we don't. Okay. Four is probably probably in the present state. Well, it should be in the present state. It may or may not be. I don't know if swap gems automatically create their resources in present. I would assume so, but state after is present, but under target. Now, stuff in the actual resource we need to set the type and flags. Okay, so flags are for implementing split barriers. There are reasons you might want these. We don't care right now. So we're just going to leave those flags empty. Type is it resource transition. All right. So that should be our barrier for the beginning of rendering. And now we need a barrier for the end of rendering. Which swaps things back the other way around. And we need to actually set the right barrier here. In theory, that should be correct. Let's try. Okay, so we don't have any complaints about resource state anymore. Instead, we just have this command allocator was reset after the command list was reported, which is not correct. So I think what's happening is we are signaling the fence, setting it to 1, and then it never gets reset to 0. So that's obviously not what we want. Instead of figuring out some way to set it to 0, I think I'm going to set this to our frame index. Present count +1. And that way, we are waiting for a different value in there every frame, which means that we will not start a next frame, think that we have already completed the frame before we even started, and reset early. This is unhappy. All right. So that should make our signal work correctly. Since it does. We're still not leaking any memory. Awesome. All right, so that's most of the actual rendering stuff that I wanted to do today out of the way. I would also like to get to compiling our shaders with DXC instead of FXC. Because while it doesn't matter for the shaders that we have right now, FXC is kind of not great at optimization. We run into a bunch of issues at work with, because we use FXC to build our Xbox shaders, and the results are not fantastic. So, in order to do that, I have downloaded the latest DXC. And so I think because we're using Visual Studio to actually do the shader build, I think we just need to change the build tool in the project. This is wrong. It needs to be later thing. Okay, interesting. So the built-in HLSL compiler for Visual Studio seems to be just FXC, and it's locked to FXC, which is not what we want. So one option is we ignore the FXC output. We can link to DXC and compile the shaders at the start of the program. That seems like the better option to me. It does mean that we have to do a bunch of mangling with library paths and igloo paths and such, but that shouldn't be too terrible. Here we go. All right. don't want to build, let's see, I just want to use it. Here we go. So we need, let's see, API. What was it? B2 allocator. We'll direct link to it. Because that's easier. Generate like it, but if it does, then we can just have this be I think this just generates like code trackable, so we can just reuse the load shader function to do this. Except we will be reading a source file instead of the file shader. We only want to create one instance of the compiler. Some IDXE directory. Interesting. Right, I know what's going on. I haven't actually set up my pass to use the new version of DXC. So, experiment. Include directories and linker. Hmm. There we go. There we go. All right. This stuff right now. Um, Even include handbook now. That would go later when we start writing more involved shader code. So this actually wants its own fancy buffer type. Go with this. Uh, Okay, so at the moment we only care about getting the, we need to check the compilation status, and then we need to get the shader out of the compile result. And then there's PDBs and reflection data and all that stuff, but we don't care about that at the moment because our shader is really simple and we don't need to debug it. Git status. It's a bit weird that that it returns an H result and it takes an out parameter for an H result. And presumably they're different things. That's odd. All right. Compilation didn't succeed. We're going to just exit because clearly something went wrong. Do a debug break here because then we can go and pull the error string out of the compile result directly rather than having to go through printing else strings, which are weird. Let's see. So now we need to get the blob out. It should be quite good. Good. Actually care about the name. Hopefully it'll let me do that. Okay. I don't know if that's going to work, but we'll assume it does. Now, create this instance. All of these need shape and power cast in. They also need to be pointing at the correct shader types. So we do also need to tell the load what type of shader to build. So we will have now we'll just have pixel shaders and vertex shaders. But so we have a vertex shader. We need to compile it as a vertex shader. So DX12. Otherwise, it's a pixel shader. And we compile it as a pixel shader. Okay, target here. Okay. We will make this more generic in the future, but for now, this will do. Okay, apparently I do have to provide this output for the name. Okay. So I don't know if these paths are correct. They should be. The working directory should be the project directory. So this should work now. Well, first I have to actually pass these parameters here. Project shader. It's shader. All right. No, that's unfortunate. Okay, I think to make this work, I'll have to actually set path to include that file, which sucks. I wish I didn't have to do that. I guess the other way I can handle it is I can copy the DLL in here. Maybe that will be enough. Let's see. Yeah, there we go. All right. Fantastic. So now we are building with DXD instead of FXC. Let's see. We have a whole bunch of DirectX warnings because we're not destroying any of our resources when we close. That's reasonable. Maybe we'll go ahead and do that. Okay. Before we can do this, we actually have to kind of is there a wait for idle here? So wait on the fence. It's seems like that. Okay, so we're going to go through and we're going to wait on all of our frame end fences. Or rather, all of our frame end events, because that will let us ensure that all of the GPU work is completed and we won't be destroying resources out from underneath the GPU. Because just because the CPU application is quit doesn't mean that the GPU has finished processing all those commands. I mean, by the time the process exits, that's usually the case. But We haven't exited the process yet. So we need to wait. Be 0? No, I guess. Okay. We can release the command list. We can go through. All our fences and release them. All of our command allocators. Reset. Released. Let's see, what else do we need to destroy? Pipeline state. Descriptor heap. Then the queue and device, I believe, as well. Pretty sure that isn't everything, but we'll. Oh, huh, okay. I guess we don't need to wait on these. Because once the window is destroyed, I guess the swap chain is gone. I don't know. This feels like we're missing some synchronization here, but I don't know how that's supposed to be fixed. Where What I do know is that we also should probably be destroying our events. Close handling this. Um, I think you're lying. I think that's initialized memory. Okay. Okay, yeah, so we are missing some kind of synchronization here. That's just kind of obnoxious. So in Vulkan, you have this concept of a wait for idle, which is you call it on a queue, and it waits for all of the GPU work on that queue to complete, so the GPU is actually idle. Because then you don't have to care about accidentally destroying resources that are still in flight. But it kind of looks like there's no such thing in DX12, which is really, really weird. Maybe it's putting on the device. That might make sense. Looks like no. Okay, so this is interesting. It's something we're definitely going to have to be better about, but we can get away with just letting process shut down and clean everything out for us. So that's interesting. All right. So we have, in fact, accomplished everything that we wanted to do today. So that's pretty cool. I think this is pretty much it. We will be back probably next weekend, and we'll start refactoring this code to be less brute force, just pushing through to get to first triangle, and we will handle resources in a more reasonable way. And hopefully next week we will be able to solve this issue with end of program synchronization, because I'm not entirely certain why that's not working. All right. I think that's the end for today. See ya.